Hello, my name is Will Brackenberry and I'm a PhD student at the University of Chicago. While cloud storage, such as Google Drive or Dropbox, is helpful for offering additional storage capacity for personal file collections, many times, organizational challenges mean such collections end up looking like this. While researchers have developed many file management tools to aid this difficulty, these interfaces either only recommend file retrieval actions, only address future disorganization, or use rudimentary heuristics. Through 2 online user studies, we built and evaluated CondoCloud, an enhanced file management browser for cloud storage that, like Celebrity Organizer Marie Kondo, helps reduce clutter. It offers machine learning-based recommendations of file retrieval, movement, and deletion actions based on the idea that users will want to manage similar files in similar ways. Just to describe our work, I'll start with our methodology. We conducted 2 online user studies, the observation study, aimed at studying participants' organizational actions, and the evaluation study to evaluate CondoCloud. Given that the methodology for the 2 studies overlapped significantly, I will describe them together. Each study was conducted in 2 parts. In part 1, we recruited crowd workers with Google Drive accounts and asked them to complete a short survey about their demographics and cloud storage usage. At this time, we also asked participants to allow our web application access to scan their Google Drive and extract some file metadata and contents. After a short delay, we invited back eligible participants for Part 2. In Part 2, we asked participants to spend 30 minutes organizing their Google Drive in the interface we provided for them, and then answer a short series of questions relating to the organizational task. The primary difference between our 2 studies' methodologies was in this organizational task. In the observation study, the interface given to participants was a bare-bones direct adaptation of an open-source web-based file browser. In the evaluation study, participants were assigned uniformly at random to conditions in which they either used the full CondoCloud interface with recommendations or used a modified CondoCloud interface without recommendations. We now discuss the results from the observation study. For our observation study, we recruited 69 participants with a median of 417 files in their cloud accounts. The most common file type was images, with JPEG and PNG as the most common extensions. Participants took 5,005 file management actions in total, most of them, 66.2%, being file moves, 16.6% as deletions, 13.1% as folder creations, and the remainder as file or folder renames. As seen here, however, both the number and the distribution of file actions differed greatly by participant. The x-axis refers to the 69 participants, with the 2 y-axes referring to the count of actions overall and the distribution of actions normalized across participants. We see, as expected, that most participants, such as this one, performed primarily file or folder movements, but some participants, such as this other, performed primarily deletions, and a small number of participants primarily performed folder creation or rename actions. This indicates that the distribution of types of actions differed for each participant. We also see that for file or folder movements, these actions typically occurred in groups. On this heat map, we are looking at pairs of actions. The y-axis is the first action in a pair, and the x-axis is the second action in a pair. The darker squares for open, move, and create folder move show that these actions went together relatively more often than others. This means it was more common, for example, for participants to move several files or folders one after another in succession, while this was less common for deletions. Notably though, when one normalizes time steps on the x-axis and takes the average number of actions across participants on the y-axis, we see that these groupings can occur at any time during the organizational process. This is because there is no significant overall slope to any of the lines. If, for example, participants tended to perform more moves early in their organizational process and fewer later, there would be a downward slope to the line. As it is, though, participants favored some action types over others and performed these in groups, the timing of when differed by participant. This leads to our design of CondoCloud. We show here the interface itself. In the portion on the right, we see a standard file and folders-based browser in which we attempted to recreate the functionality of similar, highly used file browsers. On the left, we have the recommendation pane, where recommendations for file movement, deletion, and retrieval are surfaced. These recommendations are generated passively as users organize in the right-hand browser. When a user moves, deletes, or previews a file in the browser, we use a logistic regression classifier to compare against other files in the account based on 10 content and metadata similarity metrics. We then offer recommendations to the user to perform the same action on any files deemed sufficiently similar. This functionality is moderated in several ways, both generally based on design best practice and based on the results of the observation study. In general, Recommendations are easily dismissed with a single click and do not recur once they are rejected. They're also consistent, meaning that the interface does not recommend more than one action for a single item at a time, and they are polite, meaning that no other recommendation will be provided for an item for a short period after a recommendation for that same item is dismissed. In the observation study, we saw that users may differ in their preferred actions, and once they switch action types, they may be more likely to stick with that action type. Correspondingly, we modify the classifier threshold to show more recommendations of the same type that users seem to pick more often, and we more quickly remove from display recommendations that do not match the current action type a user is performing. Once we built CondoCloud, we then evaluated it in the evaluation study. In our evaluation study, we recruited 59 participants, 36 in the with recommendations condition, and 23 in the no recommendations condition. For participants in the with recommendations condition, we show along the x-axis each of the 36 participants, and on the bottom display the disposition of the recommendations shown to them, along with the number of recommendations they received along the top. We segment participants out into groups based on the percentage of recommendations that they accepted. We see that roughly half of participants accepted at least 10% of recommendations, and 6 participants accepted nearly all recommendations. This worked out to an overall 25.5% accepted recommendation rate. We also see that many participants manually completed a recommended action without using the recommendation pane while the recommendation was active. This could indicate that they did not see the recommendation or that they preferred to organize manually. This means that overall, 36.2% of recommended actions were completed by the participants. For participants in the without recommendations condition, though they were not shown recommendations, we tracked what recommendations they would have been shown. Participants manually completed 32.0% of the move actions and 37.4% of the delete actions that would have been recommended to them. This roughly matches the overall completion rate in the with recommendations condition. This suggests that the recommendations could potentially have been valuable for these participants. We also found that the delete recommendations may have helped participants find files they wanted to delete in other folders. We show here a table that has, along the x-axis, tree distance, which is the number of clicks needed to navigate from the originally deleted file to the file that was subsequently recommended to be deleted, and along the y-axis, the disposition of that recommendation. We see that a noticeable portion of the accepted delete recommendations occur at tree distance 1, meaning that the file the participant accepted a recommendation to delete was in a neighboring folder. This suggests that, in a cluttered file tree, it's possible that CondoCloud could help users find files to delete they would have potentially overlooked. Despite this modest success, we believe there are several ways in which to improve CondoCloud. Firstly, CondoCloud does not currently group recommendations together, although a single action could spawn a large number of recommendations, more than could be displayed on screen. Allowing participants to interact with these groups as a whole could improve usability. Additionally, we need to take into account context beyond file similarity, such as the potential depth to which a file would be moved by a move recommendation. Lastly, future versions could also address the scalability issues that are currently present in the work, as currently we pre-compute the similarity values between files, while future work could potentially use techniques such as quantization or learned hashing in order to address this. Thank you very much for your time, and I look forward to your questions.